Hello again, once more, welcome back to the desk. This episode, which follows directly on from the last one, episode 15, a link to it should be somewhere on the screen. We're going to pick up where we left off. So last time we built this small little circuit here, using this little tiny 85, programmed it to make this little LED flash, and we have a little power light as well. Yeah, anyway, from small steps a great journey is made. That or you trip over your own laces. So, anyway, we've got this little circuit, excuse me, which we built last time. Now, as you can see on here, this says it's powered by a 5 volt DC supply. Now, that's coming at the moment from this Arduino Nano. It's over here. And it's getting it from this USB lead to a computer. Now in this episode we're going to change this. We're going to have a look at powering this from the DCC track power at Leopard Street. You stick around. Okay, so as noted, this little board has 5 volt DC power rails. These are top and bottom. Red one's 5 volts, linked by this red wire. The blue one, linked by this black wire, is ground. This feeds the AT-Tiny, as you can see the little red and black wires that feed that one. We've got a power supply and a little flashing LED. So this is coming in via, as I just mentioned, this Arduino Nano over here, which is providing 5 volts and ground, and then these 2 wires that come off are pinching it. So where's this get its power from? Well, in this instance, it's coming in via the USB lead, which is provides 5 volt and ground and is plugged into the PC. One thing you will note, if you do this and you actually measure the output, you'll find you haven't actually got 5 volts. You've got about 4.5, 4.6. There's some circuitry in here that you just lose a little bit, but it's not much. It can be an interesting conundrum if you're lighting LEDs and things, and what you tend to find is you can set all the brightness up, and like screen brightness as on displays. You then feed it with a 5 volt supply, and it's this little 5 volt pin it's got down here. I could put 5 volts into this as long as I didn't have the USB. Don't power it from a USB and this. Just don't. It'll power. It'll run. It would run quite happily, actually. The LEDs would be a little bit brighter, because you'd have 5 volts, not 4 point whatever. Anyway, so where does this thing get its power from? It's got, I'll bring another one of these things in here. There's another pin down here that we're not currently using called V-in. Now, this is where things start to get a little bit more interesting. You can feed that somewhere, it says 7 volts up to 21 volts. They say don't go above 12, and even then care's needed a little bit. but why? Well, if we take this one and I turn it over, see this little beastie here and the capacitors that sit next to it. Now, this thing, 3 pins on one side and a big tab on the other. This is a voltage regulator. It takes the input voltage and provides, in this particular case, 5 volts out. It drops about 2 volts. This is why you need to give it 7. It's also why a lot of Arduino starter kits, when you play around with them, come with a 9 volt battery. Now the obvious question next is, can we use this to power an AT-Tiny 85? Just moving a piece of paper out of the way there. Well, okay, it doesn't take a particular genius to figure out the answer to that's going to be yes, which just goes to show you can, with a leading question, you can go anywhere. Yeah, anyway. So, what is this thing? Can we use them separately, and how do we use it? Well, this one is apparently an AZ1117-5.0, and I'm going to be using a different one. Mostly because this is a tiny one and it's quite hard to work with. But I've got some other bits and pieces. Okay, so can we use one of these things to power the AT-Tiny 85? Now, it doesn't take a genius to figure out the answer here is going to be yes. Of course we can. Just goes to show with a leading question you can jump to absolutely anything. So what is a voltage regulator? How do we use it? Well, this one here which is, as I say, this little beastie here. This is an AZ1117-5. Incidentally, you can get the full circuit diagram schematics for an Arduino Nano on the Arduino website if you're interested in it. We're going to use a slightly different one, which is this one here. We'll come to this in a minute. This is a linear voltage regulator. Now, this is a device that varies its resistance in accordance with the load and the output. So what we've got, I'll just move some of this slightly out of the way and hope I don't destroy everything in the process. Normally, say you've got there 12 volts and ground. Say you want a 6 volt supply. Well, what you can do is you can do a potential divider. You do 2 resistors, and out here you can have 6 volt if they're similar, and you pick the resistance of this. Now, your load will have a resistance itself. So when you're designing this, you need to keep into account that these 2 resistors act in parallel. So effectively, they halve each other. If they were equal, it's like that was a 10k and that was a 10k. It acts as a 5k resistor. So you would have to put in there a 10k, a 5k. If that was a 5k, you'd get 6 volts. Or if you don't know what that's going to be, or more to the point, what if that can vary? Specifically, what tends to happen is you're going to draw an amount of electrical current through here. I don't know, 10 milliamps. You need to know what that current's going to be so you can work all of this out. Now, if you know that, fill your boots, use resistors. It's easy. They're tiny. If you don't know that, that's where these little beasts come in. So this little thing, as I say, this will keep a constant output voltage, regardless, within limits, of what you do with it. So I'll just get another little piece of paper. Look at what we've actually got. Now, it's a thing, and normally they get drawn sort of like this, just as a bit of a box. You have an input, you have an output, and you have a line that goes down to ground. And the ground pin matters. This is... I've got stuff on my desk that's just in the way. Anyway, ground matters. Ground is what you're going to measure the voltage relative to. Now, we're going to come back to that when we look in a later episode at actually using DCC signals, because you need to do it slightly differently for an accessory decoder and a function decoder. Don't worry about that for now. So if we want 5 volts there, and we've got an unknown number of volts there, we can use one of these things. Now the gizmo I'm going to use today is one of these. Now this is an LM7805. The 05 matters because that's the voltage. You can get LM7812s that'll give you 12 volts. There's ones that'll give you 3.3 volts. They're quite versatile. You can get loads. You can also get adjustable ones. There you mess around with what goes on the ground pin, which becomes an adjustment pin at that point, and you can vary the voltage. Some of those little boards you can get that give you variable voltages when you twiddle a thing. Use some of those. Some use a different type of thing called a converter. So on here we've got 3 pins: an input pin, a ground pin, and an output pin. We've got this big tab at the top. Now electrically, that's actually connected to ground. What's that for? And if we look on here, it's that bit there. What's that for? Now this tab's actually quite important. Now we're not going to go too deep into this, but one of the things you need to realise is this thing, so 7805, what we've got there is I in, and here we've got I out. This is current. They're equal. That's part of the magic of how these things work. They're equal. So say that's 10 volts coming in. And we get 5 volts coming out. Brilliant. So over here, we are going to draw 1 amp of current. And this thing will cope with that. These will cope with a couple of amps. You can get a big heat sink on the back. Spoiler alert, they get hot. So over here, we've got, now power is volts times amps in a DC circuit. I'm not going into AC circuits because it'll make my head hurt. But over here, we have got 5 watts of power. Now we also know these currents are equal. So over here, we've got 10 watts coming in. Put the circle around all of it. So 10 watts comes in, 5 watts comes out. Where does the other 5 watts go? And this is what you get. You get heat coming out of there. In this case, it'd be 5 watts. 5 watts of heat onto this little metal strip. Depending on the spec of these, you can say, you can get heat sinks that make them a bit bigger. Sometimes you can just cope with just that. The bigger the heat sink, the cooler it'll be. That can get quite hot. I've had some of these things get hot enough you can boil water with them. Obviously, you have to be a little bit careful for it shorting out, but you dip that end in the water, and it will boil water. You don't want that next to something you're doing normally. Now, this is also why these Arduino boards come with a warning. They say if you feed it through here, you're limited to about 500 milliamps anyway, just because it's USB. But say you put your 7 volts or whatever on the V-in pin, and you're going to draw current out of the 5 volt pin. Yeah, they say don't go above about 500 milliamps because all that extra heat is coming off of this. This tab here, it goes to a big copper plate underneath it. And it dissipates heat. It can get quite hot. I've had these boards where I've managed to short them out, and they've actually melted the breadboard they're stuck to. You look at it, it gets quite hot. It's not really working very well. There's a bit of a funny smell. And after a while, you lift this off, and you see underneath it's all squishy. And it's like, yeah. So we don't want to do that. This matters for later. Ideally, we want as little current coming through here as possible. But you pick suitable circuits. I mean, if you say, I need 1 amp at 5 volts, one of these, you put a heatsink on it, and you forget about it. That's what it's designed for. So, yeah. So what we're now going to do is we're going to fit one of these to this board. So before I do that, I'm going to switch it off, because I don't want it powered on while I'm doing this. So I'm going to cut a couple of bits of wire, and I'll be back in a sec. Alright, so what are we going to do? We're going to have our LM7805. Now that's going to go to 5 volt. That's going to be our input voltage. In. This is going to come down to ground, as we showed last time. Ground. Now to make this work properly, what we also want to do is put a capacitor here. It's only a little one. 100 nanofarad. This is from the datasheet. It recommends that as a stabilizing capacitor. And we want one here on the input. And this is a little bit bigger. Not much. 10 microfarad. And that'll work. So that's what we're going to build. So bring this board here back in. First up, I've relocated the power LED just to get it out of the way. Basically, I want this middle bit of the board. I've also added the screw terminals. That's going to be our input. So we will start by adding the voltage regulator, which is going to sit there. That goes in. I then need to add the pins on the back of it. So we start with the 5 volt line, which goes there. So this means it's output, and that's on the output pin. Will give us 5 volts. I'm then going to give it a ground pin, which is going to go there. assuming I can get the thing to actually go back into the board, that is. Needless to say, I have just had all this assembled just to make sure I've got all the wires to the right length. Right, we need an input pin there. So what I'm going to do, sorry for knocking the camera, I'm going to put one of these in. And this is a temporary line because we're going to be doing something else with this in a bit. So that is going to go to there. That is going to become the positive input terminal. And ground is going to be ground. So we can just do those over there. Okay, so that's that. Right, capacitors. Wires out of the way. So what I'm going to do now is I'm going to bring the output line, get this to go in. Hint when you're working with breadboard, if it doesn't want to go in, use a pair of tweezers. There we are. So that is in there. That brings out the output line. I have another one to go here onto the input line, like so. And the only reason for doing that is just to bring them onto this part of the board because I need space. So we will add the 100 nanofarad between ground and the output. And we're going to add this one here, just make sure we get it the right way around, negative leg, is going to go between there and ground. I'll do it to that side. And that's the circuit. There's another capacitor going in later. That should now be enough. We should be able to put 12 volts onto this terminal and it should work. So, to the cellar for an experiment. And here we are in the cellar. So we have a black wire and an orange wire. These come down here, just sort of a temporary mess to one of my distribution panels. So this comes up here. So I'm just going to put you in a stand and we will power up and we'll have a little look. Alright, so the big test. Remote. Power on. Power light comes on and the LED is flashing. So if I bring in a multimeter, we can have a little look and see what we've got. So I'll set that onto its 20 volt range. I'll position that there so you can see it. And hopefully these wires won't knock everything flying as they normally do. Right. Bye bye Cheshire. Push you back a little bit out of the way. Put that over here. And we'll just zoom out a little so you can see what I'm doing. Right, so I can finally untangle these wires. Don't be easy about multimeter leads. Anyway, so the input voltage. So if I plug that onto there and that onto there, yeah, 11.8 volts. That's fine. Now ground is ground, so I come over here. That's ground. Sorry. What I want is that one. 5.03. So give or take, it's 5 volts. So there we have the first experiment. We can power this thing with a voltage in and we get a voltage out. So that's step one, but that's 12 volts DC. That's not track power. Let's go back upstairs, turn this off, and let's see what we need to do to get this on track power. Okay, back at the desk. So this works. Incidentally, one thing that's worth pointing out quickly, if you have a DC voltage supply on your layout and you need something with a 5 volt supply, these things are worth thinking about. Depends how big you've got, but if you just want a local 5 volt supply, yeah, that works. So, next up, right, what we need to think of now, another piece of paper. Paper is good, we like paper. Is what we've actually got. Ooh, there's some stuff reflecting on the paper. Ooh, I like that. Now DCC, so if I do that as DCC, that's a square wave. It's doing stuff like that. Around the centre line. AC. Now my multimeter thinks AC looks like that, which is a very badly drawn sine wave. So when I measure this, it says that's 16 volts. It isn't, because it's calculating it assuming the waveform's like that. AC gets interesting. So that's not 16 volts. It's got a 15 volt supply. It drops a bit. It's a bit less than that. But what's coming in here is AC. This is a bit of a problem. Firstly, AC will blow capacitors up. AC loves blowing capacitors up. So what we need is a circuit. I'm going to draw this quite large because otherwise I always draw it wrong. That's going to go there. That's going to go up there. And what we have is 4 diodes. Which are, I think, like that. And then that comes off there. That's ground. And that's plus. So when we're in this bit of the waveform, current comes up here, can't go that way, goes through there, down here, comes back up here and goes out. We're on this bit. Now it comes in this side, goes there, and comes back and goes out. This is a rectifier, as a bridge rectifier. Something that's worth noting, this doesn't have to be DC, this could be a DC supply. And all of a sudden it doesn't matter which is positive and which is negative. This way here will be the same. The thing you need to be aware of, diodes drop 0.7 of a volt. So here we're going to be losing 1.4 volt drop through this bridge because everything's going to go through 2 diodes. Now exactly the same as we had with our LM7805, that means there's a volt drop, there's a current flow, so there's power dissipation. So these can get warm as well. They won't get hugely warm, but they can get warm. So what I need is to add one of these. Because what we're now going to do, is we're going to take that, and we're going to feed that, it's going to be the other way around this time, LM7805, so there's going to be a ground line. Coming out here we're going to get plus 5 volts, ground, and we're going to have the capacitors we had before, because I'm not taking them out. In fact, what I'm actually going to do is add another one on this side, but we'll see that. So, let's build that on this little bit of breadboard. Now, I'm not using 4 separate diodes. I'm using one of these little beasts, if I can get them out of the packaging successfully. There's 2 of them. I don't want 2 of them. I want 1 of them. So, there we go. Put that away. And bring our little board back in. Now this is a bridge rectifier. I hold it up here, and you might be able to see that. It's got 2 pins with squiggles and a pin with a plus and a minus. So if I put that way round. Now this is actually quite good. I have to get rid of these wires because we don't need these anymore. Because of the thing's spacing, I can actually put it here like that. And the 2 squiggles are now connected directly to this. I'm going to positive and a ground. So what I need to do is find my cutters and cut another piece of wire. And what this is going to give us is a rectified, but only rectified, it's not smoothed. We'll come back to making this smooth in a minute. A rectified square wave. And because it's a square wave, there isn't really a voltage dip in the middle. If this was like a sine wave, I'll just try to strip a piece of wire here. Come on, you want to play? Yeah, there we are. Got it in the end. So I can connect the ground directly. So I'm going to. So that is. Make sure I get the right pin. Zoom in. It's that one there. So that goes there like that. And I'm just going to get myself a piece of orange coloured wire. It's because I use orange for 12 volts, is why I'm using orange wire. Now, I already know, because I've built one of these things, I already know what voltage we're going to see on this. We will reveal this shortly. So I'm just going to go from there to about there. This is the very crude way I measure pieces of wire for breadboard. Because the positive of this goes into this LM thing. We're then going to add another capacitor. And we'll have a little look. Bend that, bend that. This thing comes around here and becomes the input there. Get in that appropriate hole to that one. I could have made a joke then about things being in appropriate holes, but I'm not going to. Alright. So as you can see, negative goes up to ground, positive goes into here. That'll then come out and populate things. Right. I'm going to have this second capacitor. Now this is a 220 microfarad capacitor. Not the camera again. And this is going in exactly the same way, but down here. And that, it's just going to provide a little bit more smoothing. It's two capacitors in parallel, so basically you add the capacitance together. However, this little one will charge faster, which helps smooth things out over here. This is, in effect, a stay alive. It's a very low capacity stay alive. That's not really what its functioning is here. The idea behind this is this thing is, it's smoothing out the waveform a little bit more going in. If you put a big capacitor in here, you know, a 1,000 microfarad, 2,000 microfarad, 5,000 microfarad, whatever, you would probably also want a resistor. Because when this thing powers up, this is going to suck juice straight through all this system. So you just might want a resistor just to limit it a little bit. And then it can flow out. But that is what we have here. So that should, in theory, work on track power now. Back to the cellar. Okay, here we are back in the layout. So what I now need to do is connect these wires to track power. And the way I'm going to do this is I'm going to cheat. I'm just going to bodge it. I'm going to put one under there and hope it connects to that fish plate. And I'm going to put one under there and hope it connects to that fish plate. So if I now turn the track power or the layout on, so the layout is powered up. Track power is off currently. I just have to wait for things to boot up slightly. And what I'm now going to do is turn track power on. And there we go. We are powering off track power. I have my little green LED that you can't see on camera, but that's telling me the track power is on. So let's just do this. I'm going to bring the meter back in and I'm going to stick it on AC this time. Again, where you can see the screen, and we shall see what we have. Now, so that's saying 16 volts AC. It isn't, but it might as well be. But if we go back to DC, put it on 20 volts again, because what we want to do is see what we're getting. I'm trying to do this so you can see what I'm doing. We want to see what we're getting out of this thing. Persuade that to work. Come on. Okay, so we'll try that and that one. Just trying to find somewhere I can get contact with this. It's right down here. Yeah, there we go. 13.3 volts going in. And again, just to check, 5 volts going out to the little circuit out there. Now that is taking power nicely from the track, which is pretty much complete. So what we're going to do, we're going to go back upstairs, we're going to have a little look at what we've actually got here. I'll draw you the full circuit, and then we'll have a little think about what else you can do with it. So back to the desk. Okay, so here we are back again. So what have we actually got here? Well, like I say, let's just draw this out. If I can get a suitable piece of paper. Blocking my camera. Try and find a suitable piece of paper. It should be around here somewhere. lights of my desk. I can never find anything. Right, scrap that and get another piece of paper. So, what we've actually got is a 5-volt power supply. So we're going to start off with the regulator. So LM7805. That comes down here to ground. Pootles along here. We then there have 100 nanofarad capacitor. This comes along here a little bit like this. Along here I then have, the blobs on again, a 10 microfarad, and as I said, I've put in here a 220. And this then comes along here into a bridge rectifier, minus, plus, squiggle, squiggle. And in here we are feeding it DCC. So that's the circuit we've got. And then we're coming over here and this is going into our little whatever. So there we have 5 volts. But that's not all we've got. You see, we can also take a tap off over here somewhere. And there we got 13.3 volts. Now remember when I said we want to draw as little current through this as possible. So instead of over here saying what we're going to do is we will we've got an LED over here and with a resistor, and that's currently coming off the 5-volt circuit. Next episode we're not going to be doing that. We're going to do something a little bit differently. But what you've got here in basically 3 capacitors, you only really need 2 of them, a bridge rectifier and a LM7805, and none of these components are expensive. I mean, I got a pack of, I think it was 10 of these things for about £2, I think it was. I think if anything the rectifiers were more than that. You've got a very cheap power supply. Now say you've got a layout and you've got an isolated scenic corner and you've got a little house in it. And you want to put a light or 2 in that house, or you've got a couple of houses and you want to put some lights. You could run wires all the way over to that corner, and if it's a big layout that could be quite a bit of wire. Or you could do something like this and just build yourself a little power supply in the corner. Now in the next one we're going to be looking at how to take DCC signals, so you could turn this into a switched set of lights, which is basically what we're going to do with the LED. But to start with, this is just a power supply. So you could say, I might need 12 volts. Well, you could regulate that. You can get a lower dropout version of this and turn that into 12 volts. That voltage there depends very much on what your DCC system puts in. Dinglebury, my N-gauge layout, this will be closer to probably 10 volts. So you're a bit limited. But the 5 works. So that is this one. So if I just shuffle my bits of paper around again so I can see what I actually came up with on this one. So, but there's something to keep in mind as possible. You're basically just making a power supply. Now I've had these before, and as you've seen, I've got a power indicator LED over here. Now obviously on a DCC decoder you don't want that. I've just got it so I know the thing's switched on. But there we go. So I say, in the next episode, we're going to make this jump to light speed. We are going to add the capability to read in the DCC signal. So what we're actually going to end up doing is taking a tap off here and reading that. So stick around for that one. We are then going to turn this into a DCC function decoder controlling this light. And probably a little bit more, because I also want to see this. You can set this to read from the programming track. That requires a little bit more work, but not much. Anyway, As always, likes, comments, shares, more than welcome. With that, I'll wish you a good rest of your week. I'll hopefully be back in a few days with another video, which will either be the third part of this, because I'm quite enjoying doing this, or it'll be something else on the layout. Open to suggestions. Until then, take care and goodbye.